Welcome to our Git and GitHub tutorial. If you have ever wondered how developers collaborate on projects or how your code can stay organized and updated over the time, you're in the right place. In this tutorial, we'll dive into essentials of Git and GitHub. Starting with the basics. What is Git and GitHub? We'll also walk you through the installation process on Windows and explain why version control is such a game changer for developers. You will learn the most commonly used Git commands, how to create a Git Pull Request, and even how to handle merge conflicts like a pro. Plus, we'll clear up the confusion between Git versus GitHub and wrap up some Git interview questions that will help you ace your next tech interviews. By the end of this tutorial, you will have a solid understanding of how to use Git and GitHub to manage your project, collaboration with others, and keep your code tip-toe shape. So let's get started. Before we move on, here's a quick information. If you're interested in becoming a full-stack developer, Simplilearn's AI-powered full-stack developer program is the perfect opportunity for you. This 9-month course will help you master essential technologies like React, Node.js, MongoDB, and Java with hands-on experience in over 60+ projects. You'll also learn to integrate AI tools to enhance your development process and test your applications. With live interactive classes from industry experts, you'll work on real-world projects and gain Microsoft certification to boost your CV. Plus, Simplilearn offers AI-powered job assistance including customizable resumes, LinkedIn profile optimization, and mock interviews. Get ready for your career transition with the comprehensive program designed for professionals who want to level up the web development skills. Enroll now and start building your future as a job-ready AI-powered full-stack developer. The course link is provided in the description below and in the pinned comments.
In this session, we will have a look at the basics of GitHub. Before diving deep into the subject, let's first have a look at a use case. The use case we will consider today is of the world's largest sporting goods retail brand, Decathlon. Decathlon has 1,600 stores spread in 52 countries with around 100,000 employees. The IT team of GitHub consists of 1,000 members that helps Decathlon to bring its shopper's journey to their devices. So here, we will first see the problems that they faced and then we shall see how did they sort out that problem. In the beginning, Decathlon worked on the data center with the help of a VPN. And using a VPN was a huge challenge in terms of workflow visibility and avoiding redundancies. So the first problem is how to maintain workflow visibility and avoid redundancies. Then since there are so many stores located at so many different places, hiring of developers seemed to be a difficult task as a physical workplace was always needed. So the second problem is how would they hire developers? Now let's see how did Decathlon solve these two problems one after the other. In the first case, the entire Decathlon shifted from any other remote repository to GitHub. GitHub turned out to be an amazing open source community as the code became more visible across the organization and now anybody could contribute to it. Then, let's talk about the second case for hiring the developers. As we know, GitHub is an open source community, so it helped in collaboration with any developer all over the world. The potential developers could now contribute to benefit the global community. Now the question arises, what made this contribution possible? So the major contribution role was played by the version control system. This was just a single case amongst many others. There are many organizations that have benefited from GitHub. Now, when we have realized how GitHub has revolutionized the market, let's start learning more and more about GitHub. As we move forward, let's have a look at what is version control system. Version control system are the software tools that helps in recording the changes made to the files by keeping a track of modifications done to the code. There is one repository and each user has their own working copy. The changes are committed to the repository which are possible to be seen by others. The two most important things to make changes visible are you commit and they update. As we discussed, it is a system that keeps a track of different versions of a file, and hence a specific version of a file can be called whenever needed. This makes the collaboration amongst developers easy and also provides the members of the team to work on the latest version of the file. Moving forth, let's see what is Git. Now, when we have learned version control system, the next thing we need to know is what is Git. Git is the most commonly used version control system that helps in tracking changes made to the files. Hence, we may have a record of all the changes that have been made to a file, and we can also revert back to a specific version. Git simplifies the process of software development with the help of easy source code management. Git is not only helpful and popular among developers, but also helps non-technical people to keep a track of all the files they have been working on. Git further helps in the process of collaboration and permits changes made by multiple people to all be merged into a single source. Then, Git automatically merges the changes so two people or two different sources can even work on different parts of the same file, and later on merge those changes without losing each other's work. This is especially useful when the projects are really big and many people are involved in it. Now, when we know what is version control system and basics of Git, it is time for us to jump on the topic, what is GitHub? GitHub is a service hosted on the web where all the projects are stored. Every project on GitHub has its own repository and its unique URL. Git provides a graphical interface to store the files and helps team members to coordinate on the project from anywhere. GitHub provides several access control and collaboration features like wikis and basic task management tools for every project. Let's now have a look at the features of GitHub. The first feature we will see is easy project management. GitHub helps project managers and developers to coordinate better on the project. The work can be easily tracked and updated, which makes sure that the project is on schedule and as entitled. Second feature is increased safety with packages. The packages on GitHub can be published as desired. They can be published privately or within a community, or can also be published publicly. The packages can be easily downloaded from the GitHub to use and reuse them. Next feature is the effective team management. Now, as all the team members can stay updated with all that's happening on the project, so this helps them in staying organized and well coordinated. The pull request and other modification tools make sure that the team focuses on the code. Moving on, the next feature is improved code writing. With the help of GitHub, the quality of code has significantly increased. Now with the help of Git Pull command, one can review, improve, and propose new codes. Along with that, suggestions or modifications may be discussed before changing the original code. The next feature is increased code safety. GitHub uses CodeQL, which is the industry's leading semantic code analysis engine. This tends to find risks in the code which other tools tend to miss. The last feature we shall see is easy code hosting. As the name suggests, the codes and documentations are hosted in one place. We also know that there are thousands of repositories on GitHub, so each repository has their own set of tools to release and host the code. Finally, let's have a look at the competitors of GitHub. There are several competitors in the market. Here, we have just put the most common ones. First is Atlassian Bitbucket. Then comes Fugbugs, followed by Surround SCM and GitLab. Then we have Buddy, and finally followed by Beanstalk.
Hello, this is Matthew from Simplilearn, and today we're going to delve into Git and what it actually is and how it fits within your DevOps stack. So a little scenario before using Git. One of the challenges that a lot of developers and development teams would have had is developers would be working on different types of code, whether it was database code, whether it was Python, or whether it was Java or .NET, and they would have a central server that they would be pushing all of their source code in. But there was little or no communication that was actually going on in between all the developers. The challenge you had with that scenario is that when people would be checking in code, you could be like, there'd be conflicts and you'd have to roll back different code versions. And this is really kind of the challenge that Git addresses. Git is a tool that allows all of the developers, no matter what stack they're working in, to have access to all of the code. And it makes it much more effective at being able to have development teams work on small, medium, or even massive applications. And some of the biggest applications out there are managed through a Git distributed server environment. So let's jump into what we'll be covering so you have a clear understanding of the value that you're going to get out of watching this presentation. So we're going to go through DevOps and the tools we have available for DevOps. We'll talk about what version control means within a DevOps environment and cover the two different types of version control, centralized and distributed. And then we're going to zero in on Git, which is a really fantastic distributed version control system. And we're going to go through and understand the features, workflow, branches, and commands in Git. We're going to give you a demo and then summarize all of the activities at the end of the presentation. So, what is DevOps? Well, this is one of my favorite questions. I love the idea of what DevOps is. So DevOps really is a culture of being able to deliver solutions faster, where your development teams and your operation teams work effectively together. The idea is to be able to continuously build out solutions and have testing codes that's built into your solutions, so that no matter where they are in the stage of the integration and deployment lifecycle, they're always being tested, and you can always have code getting ready to be released out. The idea is that instead of having big releases that you would have maybe once every 2 weeks or once a month, that you would actually have a continuous stream of releases, because you always have code that is being tested, you have your network that's being tested, you have your environment being tested, and you'll be able to provide feedback directly to the appropriate person, whether they're in devs or whether they're in ops, to be able to be successful at being able to deliver solutions faster. The bottom line, your dev team thinks like operations, and your operations team begin to think like developers. It's really a fantastic way of being able to speed up delivery and have your team just think and feel and act in a different cultural environment. So let's have a look at some of the tools that are available to you in DevOps environments. If we look at DevOps, it's really kind of split into two areas. The dev side, you have building, code, planning, and testing. And then on your ops side, you have release, deployment, operating, and monitoring. But the tools really all interact with each other. And what's really great is that the tools are either open source or very, very low in cost. And in fact, most of the tools that you're seeing in front of you right now are open source tools, which means there's no licensing to you, and you can actually effectively manage them and implement them within your team right now. So let's have a look at some of the dev tools that you have for doing code versioning. And so some of the tools that you may have used in the past include Subversion, Team Foundation Service, and Git. These are all different types of version control software that you have out there. One of the oldest ones is Subversion. It's a centralized version control system. It's one of the tools I used years ago. It really is good at doing what it's supposed to do, which is just a very simple version controlled solution. It's open source, so it's free. There's no licensing. There are challenges with working with it because it is a centralized tool rather than a distributed tool, and we'll get into that in a little bit. But for a very basic version control system, it does what you want it to do. Team Foundation Service Solutions, something that many of you in Microsoft world may have been using for a long time. And the thing that's great about TFS is that it's built right into the Microsoft environment. It's the server side, the services side of building out your solutions with Microsoft. Just recently, in the last couple of weeks, at the beginning of September 2018, Microsoft actually just rebranded TFS as Azure DevOps, and so you have Azure Pipelines, and there are 5 now Azure tools that actually replace TFS. But these are all tools that are very similar in concept. The old TFS tools are very similar to the centralized SVN tools, whereas the new tools that are part of Azure are actually much more aligned with Git. So what you're seeing is Microsoft moving from the centralized server to a distributed server with their new Azure DevOps tools, which is fantastic news for every developer listening to this. And then we have Git, and Git is a distributed version control system. It is, again, open source, which means that you can start using it right now without fear of having to have any costs or any penalties. And the thing that's really good about it is that you can use it for almost any kind of digital project. And what it's good at is being able to create that historical record and versioning of your source code, whether you're doing a web application, a mobile application, or you're actually building a Python script for a machine learning solution. So let's dig into what version control systems are and how they can be of value to you. So the role of a version control system is to allow developers to be able to check in their files into a repository. And here you can actually see how we can check in 3 files into a repository, and that repository then becomes a snapshot or a historical record of the files that we're working on. And you want to be able to have it so that the repository is flexible enough so that as you want to be able to scale and add in new files or new versions of a file, that you can actually do that easily within your VCS environment. And the goal is to be able to constantly have each of these versions available so that anybody that wants to be able to check out the file can actually have the latest version or see a history of how that file became what it is today. Let's look at centralized version control systems, and then we'll compare it against distributed version control systems. So a centralized version control system has a central server where all the files are stored, and everybody has to check in and check out from that centralized server, and all of the versions are managed within that server environment. The problem is that if that central server crashes, which doesn't happen but very often, but it can happen, you end up losing all of your files. And I was actually on a project where that actually happened to us, and we lost 6 months of history of how the application was created. Fortunately for us, we actually had a backup, but it didn't have all the historical data, so we were able to at least continue working, but we just lost a lot of files and it took a while to get back into place. So let's now look at and compare this to a distributed version control system. With a distributed version control system, you still have a centralized server that manages the files. But the difference is that as a developer, you check out all of the files for a project. So you can actually manage the whole project locally on your development machine and make your changes. And then you can just check in and out the changes that you've made to the centralized server. The opportunity you have here is that the server itself, if it goes down, you're not going to be in a situation where you lose all of the history, because everybody that's working on the actual application has all of the versions of the code locally on their machine. Now, one of the more popular distributed version control systems that out there is Git. I mean, it really is probably the most popular by a margin compared to a system out there. So, let's dig into, what actually is Git. So Git is a version control system for managing files, and as a developer, you have a Git client on your machine, and you're able to make changes and create local repositories of a program on your computer, and then you can sync up with a remote service such as GitHub or GitLab or the new Azure Labs environment, where you can actually store files remotely and then allow remote teams to have access to those changes in the actual application you made. So you can track your changes easily. The tool is inherently distributed, so it makes it very easy to manage the code for large teams. And you can bring people in very quickly, and you can have people come in as specialists and spin them up quickly and have them work on a piece of the code and then drop them out of the project. If you want to have a check on how this works, go and start contributing to any of the many thousands of open source projects like GitHub, where you can go in with your Git tools and just contribute to those projects. And then finally, one of the things that I really like with Git is that it's not a linear development approach. It's not starting from A and going to Z. It's a non-linear approach, which allows you to have branches that people are working on in parallel to your master branch, where people are actually doing the delivery of the production code. So let's step through some of these features. So Git, as you can imagine, the first thing it does is track history. That's probably the most important part of having a version control system. It's free open source. You can actually go and use it right now. There are no costs for actually using it. It is a non-linear environment that allows people to be able to build out new features in parallel to the master branch, so that you can be constantly having the master code out there and adding in new features without breaking the code. And you can automatically create backups because each developer has a version of the code remotely. It's incredibly scalable. Some of the biggest projects out there now are being managed through Git. And because of this scale, the collaboration becomes a byproduct of teams working together. And branching just is so much easier within Git. So as you can see, this whole thing leads to a very effective distributed environment. So let's step through some of the workflow that we have available for Git. So the way that Git works is that you as an operator, as a developer, you have the Git client on your local development machine, whether it's a Linux machine, a Mac, or a PC, and you connect to a remote server and you pull down the latest working copy, and then you're able to make all of your changes locally, and you can modify the codes, you can review changes, and you can commit those codes to your Git repository that you have locally, and then you can push those changes back up to the remote server. And as soon as you push them into the remote server, those changes then become available to everybody else working on the project. So they can be constantly keeping everybody updated on all the work that is happening. So, typically the way that it would work is, you would start off with having the working file, the working directory that you have locally, and then you would stage those files into a staging area, and then you get those files ready to be committed to your Git repository. And these are all actions that you would do locally and then connect to a remote server. And then later, when you go back into work on your project, the first thing you should always do is check out that code so that you always have the latest version of the code and everybody's kept in sync. So let's talk about branching in Git. So the way that branches work is that if you imagine you're working on a project, and projects always have a tendency of getting bigger than you imagine. And what you want to be able to do is keep that main product working and keeping it working effectively. But if you want to be able to add a feature to that product, you may have 2 or 3 different groups that are working on multiple features simultaneously. And what you want to be able to do is give them the freedom to work on those individual features. And the way you do it in Git is that you can create branches off the master, and while you're off the main branch, which is called the master. And so each person could be working on their own separate branch, and then when they want to, they can then later merge those branches back into the main master. And all this time, the main master still works and still able to produce the right code for the customer, but at the same time, it allows the developers the freedom to be able to write in their new features. And so we can look at this in a little bit more visually with the master branch. And we can put in small features and large features, and we can then merge them back as we need to. So this kind of covers some of the commands that we have in Git. So the first command you'd want to use is called git init, and that's allowing you to go into a folder on your local PC or your local Mac and convert that folder into a local Git repository, and that creates that repository. Then you want to be able to make changes to that repository, and the commands you'd be using in this instance would be add, commit, or status. You want to be able to sync your repositories with the remote server. So be able to put the code that you have on your computer on the remote server, you use push. You want to get the code from the remote server, you'd use pull and then add origin. And then if you want to do parallel development from the master branch, the main branch, you would use branch, merge, or rebase as ways to be able to do parallel development. And now we're going to go through and do a demo on Git. So we're going to do a demo on Git so you can feel comfortable running the commands in the interface and you're able to get Git running correctly in your environment. So the first thing we're going to do is we're going to set up which version of Git that you have, and then we're going to see if we can establish some global configurations within your Git environment. And we're going to do sandeep.dash as the name, the email address is sandeep.simplylearn, and then we're going to do a list of the different configuration settings we have. So to check the version of Git that we have, we do git -- version in our terminal or command line window. You can also use PowerShell. That will actually get you running in the same environment as well. All of these tools are going to be command line tools. And then the next thing we're going to do is we're going to assign some global usernames and a global email address so that we can actually access the Git account itself locally on the device. And so we're going to put in config -- global user.name Sandeep, and then git config -- global user.email and sandeep.d@simplylearn.net. And now we're going to check the list of usernames and email IDs in our configuration environment with -list, and you'll see that we have everything in there correctly. Here is our username right here, and our name, and our email ID. So if you need any help when you're actually doing any of your work in Git, all you have to do is do git help config or git config -- help, and this will allow you to actually get access to the help screens. So let's just go and type that in: git help config, return, and this takes us to the help page that's running locally on your device. And here we have a breakdown of all the different commands and what those commands actually do within a Git configuration. And we can go ahead and we can do git config -- help, and that will actually take us to the same page. So two ways of doing the same thing. So we're going to go ahead and we're going to create a test repository on our local system, and we're going to do that with make directory called test, and then we're going to move our cursor within command window, terminal window, to the test folder, and then we're going to initialize that folder to become a Git repository. So let's go ahead and do that. So we're going to make a new directory and we're going to call it test, and we're going to move the cursor so it's actually in the test folder. We do cd change directory to test, and you can see now we're actually in the test folder. And now what we have to do is initialize this folder as a Git repository. And so we're going to do this as git init, and it's now a new Git instance that we can actually now use for managing our Git environment. So we're going to create a new file and we're going to call it info.txt, and we're going to put some content in it, and we're actually going to put it in the folder that we've just created, so you can actually see what it's like to test out the Git environment with a file that hasn't been checked into it yet. So let's go ahead and do that. So we open up our folder directory, and here you can see we have the test folder, and we're just going to go ahead and create a default test file. So right click, text, new document, info.txt, open that, and you can put really whatever you want in here. We're just going to put in this information right now: name equals Sam, registration number 12479, and save that file, close it out. Now if we actually go ahead and run a git status command, you'll see that the info.txt file is in red. That's because that file has not actually been checked into the project. It's a new file that we've added, but it hasn't been committed yet into the Git repository. So let's go ahead and see what it takes to actually add the file to the Git repository that we just created. So we're going to do that by doing git add info.txt, and then we're going to commit that into the history of that Git repository. So it now has version control, and we can start doing forking and other kind of similar activities when we connect later to our GitHub Git environment. So we do git add info.txt, and remember we're actually still in the test folder, so it's going to look for that file in that folder and just add it in. And now if we go ahead and do git status, we'll actually be able to see that the info.txt file is in an active color. First of all, we have to commit it, so we go git commit -m, and then we're going to commit, and we add in some quick text here. You can write whatever you want. Committing the text file is now actually committed into the Git repository, and it's still running locally on your PC. So we're going to go make some changes to the file, and we're going to save it, and we want to be able to see how we can use Git to compare the differences between the two files. So let's go over and we're going to make some changes to the info.txt file. Here we are, here's info.txt. We're just going to add in a new line. We're going to add in the line address, and we're going to save that file. And now when we go over to Git, we're going to be able to review the difference. So we're going to do git diff, and here you actually see that we've added in a new address file. So now you can actually see this is the difference between the two documents. Now, as you can imagine, when you have code, this would become more elaborate, where actually will show you code that's been pulled out if you've eliminated any code, or if you added in new code. Really useful. So we're going to go ahead and add our Git username to a remote location, so we can actually start testing out the file that we've created into a remote repository. In this case, we're going to use GitHub, and you'll be able to see how we can actually then save that file into a Git repository that somebody else could then access and be able to make edits to. So let's just go ahead and make those changes. So git config -global user.username, and we're going to do Simplilearn, and that will associate it with this Git repository that we've just created locally. So Simplilearn-GitHub. So Simplilearn GitHub is the username that we use on GitHub. So we're going to go over to GitHub. Here we are in GitHub, and then correct new repository. And then, as you can see, we're So we're in Simplilearn-GitHub, and we're going to call the new repository test. We're going to make it public so anybody can access it. And you'll see that it automatically adds a README file. And we have our test environment set up correctly. So we'll go ahead and copy the URL link, which is github.com simplilearn-github/test.git. Copy that, and we'll go back over to our command line window. And so now we're going to add the username to the GitHub configuration. So what we're doing is we're connecting the local repository to the remote repository. So we type git remote add origin, and then we'll paste in the address. And this then allows us to connect the local repository that we created in the test folder with the remote repository. And now we're connected. So now that we've connected, we can actually push the file that we have in the local repository on your PC or Mac to the remote repository in the GitHub server environment. So let's go ahead and do that. So we're going to do git push, and push is the command to push the documents from the origin, which is the local file, to master, and master is a remote file. Hey, and there we are. Success. So what we have now is the file that we just created in our local Git repository is actually now in the remote repository as well, so that anybody can access it. So let's go have a look at that. So we're going to refresh the GitHub page, and hey, there we are. There's info.txt has been uploaded, and we're ready to go. That's great. That's what you should be seeing. So refreshing your web page on the remote GitHub folder, and it could be any Git service, but just happen to be using GitHub because it's free to use. You'll be able to see that the local file has been installed and is now part of the Git repository in the remote server. So what we're going to do now is we're going to create 3 more files, and we're just going to call them info.txt, info2, and info3, and then we're going to push them out to the remote server, and we're going to merge everything together into a single environment. So let's go ahead and create those 3 files, and we're just going to add those into the folder. So let's go ahead, create new text document, info1, and then we're going to create info2, and then info3. I'll get my typing right here. Okay, here we go. There we are. Okay, I'm opening info3, and I'm just going to enter some text in here. And what we're going to do is illustrate how we can do branching. And each of these files I'm going to save and then close out. And now I can go over and... So let's create a new branch. And we're going to call this one first_branch. And we go git branch first_branch, and this will be a new branch of the code environment that we're creating. And so hit return, and that allows us to create a new branch. And so what we do is we're going to move to the new branch. So we're going to do git checkout first_branch, and that allows us to move into that branch. And you see that info.txt is already there, which is good. That's what we want to see. Now what we need to do is add in the new documents. So here we have the different steps we've taken. We created a branch, we moved to the new branch, and now we're going to go ahead and add the info3 txt to that branch, so you can actually see everything coming together. And we're going to go with git add info3.txt. So we're just adding a file like we were previously with our initialization, our first initial Git folder, and that file has now been added to the first branch. So we're going to go ahead and commit the file to the first branch, and then we're going to merge the documents into the master branch so we have everything together. So let's go ahead and do those steps. We're going to do the commit first, and then we're going to merge everything together. All right, so we do git commit -m, and we're just going to say made changes to first branch, and that's just documentation so that we know what we've done. And there we are, we've committed the file. So we had that file info3 txt committed, and now we're going to go ahead and merge the files into the main master, and so we can actually have everything together as one consistent environment. And we do that by typing in. So this lists out what we have in our master file. So we just do ls, and that shows everything in the folder. And we have info.txt, info1 txt, info2 txt, and info3 txt are now all in the first branch. So let's go ahead and we're going to merge. Okay, so actually before we merge, we have to check out the master branch. So we do git checkout master. So it gets us into the master branch, and you'll see that we have just one file there, info.txt. So we're going to list out the files in the master branch. And so what you'll see is info.txt, info1 text, and info2 text are there. But info3 text isn't there because that was created in a separate branch. So let's go ahead and merge the first branch into the master branch. So we do git merge, and we do first_branch, and there we are, we've merged it in. And excellent, that looks good. So let's go ahead and list out the files that we have in the master branch, and we do ls, and then you'll see that we have 4 files, including the info3.txt that we had in a separate branch, now all in the master branch. So there we are. We've gone through and we've looked at the different commands and controls that you have for working with Git. And as we've established in this presentation, we talked about version control systems, why they're important, but why distributed version control systems differ from your traditional version control systems, particularly when you have global and remote teams. We've covered what Git is and the architecture of Git, and the various concepts you have with Git, such as forking and cloning, being able to add collaborators to be able to work in your projects, branching and being able to pull and push code from a remote service. And then finally, we did a full demo on how to use each of those commands within a normal environment running on your local computer.
Anjali from Simplilearn, and today I'll be showing you the installation for Git on Windows. So we'll start by downloading and installing Git on our system. We'll then have a look at the Git bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository. And finally, we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows. And I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system and it's downloading. So this will take a while. So Git is finally downloaded. Now we need to install this on our system. Click here, run. So go to next. We don't have to change this path. Just click on in quick launch and on desktop. Next. Next, again next, nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes, we just want to launch the Git bash. So let's just tick that and then click on finish. And your Git bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command. And as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command, just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config -- help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test, and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello Simplilearn. Save this file and go back to your bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared, it's visible, but nothing is committed yet. So this means that we have not made any change to our file through the Git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as we can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile and my username is Simplilearn-GitHub. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, Simplilearn-GitHub, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo. If you have any queries regarding this, please post them in the comment section below and we'll get back to you as soon as possible.
We shall learn the concept of version control in general. We shall learn the basics of version control system, followed by the benefits of the system, and finally, we shall have a look at some of the best version control systems in the market. But before we begin, make sure you're subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simplilearn. To start learning about the version control system, let's begin by talking about a use case. Imagine there's a multinational company that has offices spread over several countries with thousands of employees. So when it is such a big company, there might be a set of issues and challenges it would face. What could be the possible set of challenges the company faces? The company faces the challenge to collaborate. There are so many people located at different places. There may be a need to communicate for a particular reason or a set of people who are working on the same project but from different regions. Second challenge is related to storing versions. The project is not completed in a single version. There may be n number of versions. In that situation, the problem of storing all such commits in a single place is a huge challenge. Then another problem is restoring previous versions. Sometimes it is important to go back to the previous versions to find the root cause of any bug. One more common challenge is to figure out what happened. At times, it is critical to know what changes are made to the previous version of the source code or where exactly has the changes been made in a file. Then comes the problem of backup. In case the system or the disk of the user breaks down and there is no backup, then all the efforts will go in vain. These are some of the basic problems that any small or big company might encounter. Now the question arises, what could be a possible solution to all such problems? And this is when the version control system comes into picture. The version control system will take care of the collaboration between employees, storing different versions, will help in having backups on the remote repository. It will also help in rolling back to the previous commits and to the last version of the source code. We will talk about each of these reasons in detail when we learn the benefits of the version control system. Let's first have a look at what is version control. As the name version control suggests, it refers to the category of software tools that make it possible for the software team to look after the changes made to the source code. The system records all the made changes to a file, so a specific version may be rolled if needed in future. It is the responsibility of the version control system to keep all the team members on the same page. It makes sure that everyone on the team is working on the latest version of the files, and most importantly, makes sure that all these people can work simultaneously on the same project. Let's try to understand the process with the help of this picture. There are 3 workstations or 3 different developers at 3 different locations, and there's one repository that is acting as a server. The workstations are using the repository either for the process of committing or updating the tasks. There may be a larger number of workstations using a single server repository. Each workstation will have its own working copy, and all these workstations will be saving their source codes into a particular server repository. This makes it easy for any developer to access the task being done using the repository. In case the system of any particular developer breaks down, then also the work won't stop, as there will be a copy of the source code in the central repository. Now, after knowing the basics of version control, it's time for us to check the benefits of version control. The first and the foremost advantage of the version control system is that it helps in managing and protecting the source code. The system helps in management of the source code for the software team by keeping track of all the modifications that are being made to the code. It also protects the source code from any unintended human error and consequences. Then the next advantage is it keeps record of all the modifications made to the code. As we learned in the previous step, the way it manages the code for the software team. The team is working continuously producing new source codes, and it is making amendments to the already existing code. These changes are to be recorded for future references, and in case they are needed to discover the root cause of any particular problem. Then the third advantage here talks about comparing earlier versions of the code. As we saw that all the versions of the source code are saved. This makes it possible for developers to go back at any time and compare the earlier versions of the code to help fix the mistake while reducing disruption to all team members. The fourth and the final benefit we shall see is that the version control system supports developers' workflow and not any rigid way of working. Any good version control system will not impose any particular way of working. The version control systems are known to provide smooth, continuous flow of changes made to the code and prevent developers from getting frustrated in the course of this mechanism. Now, towards the end of the video, let's have a look at some of the best version control systems in the market today. The first one here is GitHub. Then comes GitLab, followed by Perforce and Beanstalk. Then on number 5th, we have AWS Code Commit. Moving further, we have Apache Subversion, Team Foundation Server and Mercurial. Finally, we have Bitbucket and Concurrent Version Control.
My name is Chidanand and I am with the Simplilearn team. Today, I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash on the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git Bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git Bash. But what does it take for you to share this repository with another user who has also got Git Bash installed on his system? This is where you would need something called as a Git server. So for user 1 or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free. Some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user 2, the first thing that I got to do is have an access to a Git server where both user 1 and user 2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user 2 or the other developer who wishes to collaborate with me on this repository can use his credentials as long as he's registered properly on the Git server. He can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server. So that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git Bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git Bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client. I need this one. So this is the Git client or the Git Bash that I was referring to. It's about 40 megs. And let me just download this, pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. Alright, I go ahead choosing all the default options. I want it to be installed in C:\program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch git bash. So what I get is this window. So this is the git command prompt. So let me check if everything is looking good. Say git version, it sounds good. Say git help. All right, a lot of git help commands. Everything looks good. So I ended up installing the git bash. I can go ahead with all other commands. Now that I have git bash installed on my system, let me open up a git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the git bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete that in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory. a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder, and by default there is a branch called master, and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a Git notices that there is a new file in this repository called master.txt. If at all you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the create repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got two commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. Alright, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. Master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that. That's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase, because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated, and by default it is created in this particular folder. So let me go over to that particular folder, and this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings, and you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I will click on new SSH key and let me paste my public key that I've copied, and I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right, now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right, pretty good. I've been successfully authenticated. So that means now my SSH keys are good, and just by using my passphrase, I can connect to my GitHub server using SSH. All right, so for the second use case, what I would do is create a repository on the server with some content in it, and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository, and let me kind of initialize that with a readme file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some readme file in it. A random readme file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random readme file with some content in it gets created, and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push to be on the safer side. I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial. when I created a repository on the server, cloned it, made some changes to the repository, and pushed it to the server using SSH. A quick recap of all the Git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a Git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 file, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted. All the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a Git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit, and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. All right. So this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all the Git server would not allow him to go back in history, but assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who are using this repository collaboratively, and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does Git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead. From C5, I see another commit. But what was there as a part of this commit? Actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation, both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch, and once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. All right, this is my folder here. All right, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this, save this content. Alright. So if at all I do a git status, I just see 2 files in it. So let me go ahead and add these 2 files and let me commit my changes. So git commit -am or -m, first commit. So if I do a git log, I see only 1 commit and there are 2 files here. You can see those 2 files that is here. Alright, so at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch, name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these 2 branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly 2 files the way it was earlier, because I've created a branch from my base branch, which is the master branch, and when I created a branch, there were 2 files existing here. If you see the content of these files, they would all be the same. Alright, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical Git folder. So what happened is, now Git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So Git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and Git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server. And let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right. I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in 2 branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these 2 branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. Alright, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -- delete and the name of the branch. All right. So this went ahead and deleted the branch from the server. Let's check that. Okay. If you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git check out the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin --- delete and the name of the branch. This would also delete the branch that you created on the server.
In this session, we will be talking about Git Pull. In the previous video, we discussed the basics of Git, GitHub, and Git Push. We learned how Git Push is used to push the content from the local repository to the remote repository. You can watch that video by clicking on the top right corner. Today, we will learn how we can pull the content from a remote repository to a local repository. So without any further ado, let's get started with what is Git Pull. Let's say we have a project on a remote repository, GitHub, and now we want to bring that project onto a local repository or to our system. So for that, first, we will fetch that project to our origin master. What origin master does is it fetches changes from the locally stored branch and merges that to the local checked out branch. So in the next step, the origin master will merge that project with the branch and it will eventually reach our local repository. Both processes together are known as the Git Pull Request. Now, let's see the process in detail. As we saw in the previous part, Git Pull first fetches and then merges the changes from the remote repository to a local repository. So now we know Git Pull is a combination of two commands, where in the first command, fetch is executed and then in the second command, merge is executed. This collectively completes the process of Git Pull. Now, let's have a look at what these two commands do. Git fetch command commits files from the remote repository into a local repository, while the git merge command combines multiple commits into a single commit. It merges the branch from the remote repository to the local branch. Now, when we know about the basics of git pull, let's go on to see the working of git pull with the help of a demo. In the demo, first we will pull content from our remote repository to our system. Then we will make changes in that folder and push it back to our remote repository. So now we will begin with opening Git bash and creating a directory into it. The directory that I will create is, I'll create it with the name git_demo. After I've created the directory, I'll check its location. I'll go to the directory. We can see there's nothing inside git demo as of now. Then I'll create the directory with the name changes. Then let's go and navigate this directory as well. We can see there's a folder with the name changes. As of now, this folder is also empty. Now let me create a repository for this folder. We can create a repository with the help of git init command. As we can see, now an empty Git repository has been initialized to our changes folder. We can go back and check. Here in the changes folder, we can see a .git folder is there. This folder is hidden. I can see this folder since I've enabled my settings to view the hidden files. If we get into the folder, we see a bunch of directories and configurations. Make sure you don't make any changes to any of the directory. Now let's go back to our git bash. Now let's pull the directory that we created in the last demo of git push. For that, we will go to GitHub. In the GitHub, we will go to a directory. Here we'll go to clone or download and copy this URL and paste that URL here. When we paste the URL, we can see the contents being pulled back. Here, when the contents have been pulled back, let's go and check the contents. When we go back to that folder, in the changes folder, we can see git demo, alpha and beta. If we go on to check the content, in the beta we have beta, alpha, gamma. In alpha we have alpha, beta, gamma, delta. While in the git demo folder we have the git ppt and the git pdf. So now we will make changes in these two notepads, and after that we will push that same notepads back into the same directory. Now let's open the notepad first. For opening the notepad, I will put the location of those notepads. The name of our notepad was alpha. So in alpha, I will delete alpha from here. I'll save it and close it. Then I'll open the next notepad, that is with the name beta. Here I'll delete beta from here, save it and close it. So now let's check the status. In the status we can see alpha.txt and beta.txt are modified. So we will use the git add command. Now to commit the changes, we will use git commit -m changes made. We can see 2 files change, 2 insertions made and 2 deletions. Now let's check the status of the file again. Now when we check the status, we can see there's nothing to commit at all and the working tree is clean. Now when the changes are made, we will push all these files back to our repository. So for that, we will go back to GitHub. Here in the GitHub, we will copy this URL, come back here, then we'll type git remote add origin and paste that URL. In the next step, we will write git remote -v. We can see the fetch and the push command in order. In the last step, when we have to push everything back, we will write git push -u origin master. Now we can see the contents have been pushed back to GitHub. So let's go back to our GitHub and check the contents. When we go back to GitHub, let's refresh it and see the contents of the file change. We can see the changes made, the commit name that we had given. So when we open alpha.txt, we can see there's no alpha. We have deleted it. It's beta, gamma, delta. And when we open beta.txt, we can see beta has been deleted. Only alpha and gamma is there.
Now we all have worked on Git and we know that Git is a very good version control system which we have all together. But how to resolve a problem which is known as Git merge? Because during the developers check-in or do any kind of merge activity, this is a common problem which they face on daily basis. Now this is something which we are going to talk about in this, so that we can give an kind of an insight to all those developers and to other particular different people who are using the Git version control system here. Now what exactly we are going to talk about here? We are going to talk about what exactly is Git version control system. We are also going to talk about what exactly is the basic Git commands used in Git. And then we are going to talk about that what exactly is a merge conflict all about. And then the different type of merge conflicts which we encounter while doing any kind of merging or any kind of modifications, and then how to resolve these merge conflicts faced by a particular individual or a particular developer. And then the last one is that the various Git commands which is involved in resolving these conflicts. And then we will be going on with a small demo to better understand that how these conflicts can be resolved altogether. Right, so let's first of all talk about that what exactly is a Git version control system. Now Git is a kind of a version control system which we basically used for storing a kind of source code there, which can be used for storing a source code of Java, .NET, Android, Node.js. Different kind of programming languages can be stored all together in this version control system. So in an organization, you will be having a full-fledged version control system known as Git. Now you may be having different projects, different repositories, multiple developers, multiple collaborators working on different projects. So it's a very extensive tool which is used by different developers, and in fact it is not only limited to developers. A lot of other people also exactly use this specific tool. Now the main task of using this tool is to perform a better coordination of the work here among the different people, among the different developers, and also to have a proper track of the particular progress of the specific project. So using the repository, you can see that over the period of time, you can do the tracking that how the different commits are happening here, how the different source code modifications are being done. So the complete status and the complete stats you will be able to get from this a kind of a version control system here. Now it's mainly used for source code management here in particular software development process or a particular team here. So it's a very important and in fact a key tool for any kind of development project. So the development cannot survive without having a Git version control system. Now Git favors both programmers and non-technical users. Now, if you are a programmer, definitely you will be using it for storing the source code and having those particular files, having some .NET source code, Java, or some particular source code present there. But in fact, if you're not a particular developer, if you're not a programmer, you are working as a non-technical job. So in that case, also you can store it for keeping your project files. Best example, a particular DevOps engineer can also use these repositories to store their version control systems, to have the scripts, Python scripts, shell scripts, configuration management tool scripts, any kind of automation scripts they can store, they want to have it, they can keep use of these particular version control system here. So it's not a dedicated tool for a particular developers. Anyone who wants to utilize the features of version control system can make use of this specific tool. In fact, it allows multiple users also to work together, so different people and different programmers can collaborate with each other with the help of this particular specific tool here. And it can also handle large projects. If you feel that you are working on a particular big project which is having multiple repositories, multiple projects are there, so in that situation Git version control system will survive and will provide you a better performance in different aspects. So it's a very good tool for you to handle big projects where you are involved with multiple changes, multiple programmers, multiple collaborators, and different kind of source codes. Now, what are the different basic commands which we use in Git to manage a Git repository? Now, first of all, a very basic command of a Git over here is git config. Whenever we work with any kind of Git repository locally, when we do a Git clone and we manage or we do the modification to the Git repository locally there, so in that situation we often have to provide some details like the username, email ID, so that whenever we do some kind of commits, the author details should be submitted according to that. So in that situation, we have the particular command called git config, which will definitely help us to do some configurations, so that we will be able to have some configurations configured, and we will be able to have some author details or some additional parameters. So all those things we can configure using this git configure command here. Now, if you want to initialize a local repository, now you're not working on a remote repository and you want to initialize a local repository, in that case you can use the git init command in a specific folder, so that you can convert that a simple folder in a full-fledged git version control repository. So init command is used to initialize a local empty bare git repository. Next command is git add. Now git add command is used whenever we do any kind of modifications into my local repository. So that file will be present into the working area, into the working copy over there. Now the moment you run the git add command on couple of files or on an individual file, so what will really happen, that all those files will be added to the staging area. Now why these files are adding to the staging area? So that at any moment of time when you run the git commit command, these files will be picked up from the staging area and will be preserved permanently into the Git repository. So when you do git add command, it moves the files from your working copy to the staging area, and it will remain there itself unless and until you don't do any kind of git commit command further, so that these files from staging area will be permanently written off into the local repository. So it's a very important part that you run git add command before running any kind of git commit command. Now git commit command will only pick up those files which is present in the staging area. So if you have done modifications to 200 files or 20, 30, those kind of files there, if you do the git add command only for 5-6 files, so only those 5-6 files will be taken care in case of a particular commit. So you need to make sure that you select the desired amount of files before doing any kind of git commit activity. Right? Now next command which we have here is git diff command. Now git diff command is a kind of best tool which we have here, which really helps us to understand that how we can check the difference between two files, and in fact this git diff command can also be used to see the difference between two different branches also. So if you feel that if you have done some changes to the file to a specific content here, now if you want to see the difference between your particular head revision number and whatever the modifications you have done right now, so in that situation you can run git diff command. It will let you know that what the different kind of changes and modifications you have done. So if at any moment of time before doing any kind of commits, you want to do some kind of review, you want to see that what different changes you have done, so in that case you can go for the git diff command. So git diff command used to see the content, the difference or the modifications which you have done recently to the specific file. Right? And the last one, we have already discussed the git commit command, which commits the changes to the head revision number, and these commits are something which is stored locally, and you will not be doing the direct commits to the remote repository. So commit is something which is done into your local repository only. But yes, this is the last stage of doing a modifications there. Once the commit is done, it will directly modify your history, your Git repository history there, and the changes will be permanently preserved into the repository. So Git command is primarily used for permanently preserving the changes into your local repository. Right, so these were some of the commands there. Now there are some further commands also. Let's discuss about them. Now next command is git reset command. At any moment of time you want to do some undo activity for some local changes done to your local repository into your Git repository. In that case we can use the git reset command. Then next command is git status. Now git status command will show you the state of the working directory and the staging area. So both these area will be shown when you run the git status command. If you have done any kind of modifications to the working area, that will also be visible to you, and if you add some files to the staging area, that also will be displayed using the git status command. So git status command is very important because ultimately it lets us know that how the different things and then how the different files are modified over here. Right, the next thing is git merge here. Now git merge is a very specific command which is used to move the changes from one branch to another. Now at any moment of time, if you feel that you are working on some other branch like develop branch or some other feature branch, and you want to move the changes from this feature branch to the master branch, so in that case you don't have to do the commits all together again in the master branch. All you can do is that you can go to the master branch and trigger the merge activity. So this merge activity will check what is the difference between the two branches, and whatever commits is missed out, it will also be synced back into the master branch. So git merge actively helps us to move the changes from one branch to another one. Next one is the git push command here. Now git push command will eventually help you to move the changes from your local to move the different commits from your local repository to the remote repository. Now in this case what happens that if you are working in offline mode, if you have done some couple of commits, now git push will help you to sync those commits back to the shared to the remote repository. Now these remote repository can be GitHub, Bitbucket or GitLab. That is a different story, but yes, all your changes will be synced or will be moved from your local repository to the remote repository. Right, and the last one is the git pull. Git pull is an opposite activity of push here. Now you might have seen that some other developers are also doing some check-ins or some push activity to the remote repository. Now if you still work on an old version of your source code, it may cause a lot of problem for you. So at frequent intervals you may have to pull the changes, or you may have to download some changes from the particular network or from the remote repository. Now once that is done, you will be able to see that those particular changes will be pulled down, and you will be pretty much able to do the you will be able to fetch and download the changes from the remote repository to your local repository here. So this is an activity which really helps us to understand that how we can pull some changes from the remote repository to your local repository, so that you can have the latest source code which might be pushed by some other developers or by some other collaborators, so that you can always work on the latest source code into your local system. So this is again a mechanism in which we are trying to see that what are the different git commands we can explore and we can utilize here to interact with the Git repository. So this was some of the basic commands which we can use for managing the Git repositories here. Now let's talk about that what exactly is a merge conflicts. Now merge conflict is something which gets originated the moment we do some kind of merging activity. Now merging is a process in which we move some source code from one branch to another. Now all the developers cannot work on the same piece of branch there. So what really happens that in that situation, all the developers mainly work on some couple of branches and then they all collaborate to some other branch, or different developers try to push their changes from the local repository to remote repository. So in all these situations, the source code gets moved from one location to another. Now what happens, in as per this diagram, we have a remote repository over here. Now all we are trying to do is that we are trying to push some source code over here from a particular developer here. Now he is doing the pull and push activity, and this another developer is there who is also doing the pull activity here. So merge conflicts basically happens then. For example, this particular developer A is trying to do some push, right? So that push is almost done here, and when the particular developer V is trying to push the particular results or try to push its own content to the remote repository, he got a merge conflict, which means that his particular developer B merge activity is cancelled, is deferred here. Now it could be a possibility because of the changes on the difference on the two piece of source code there. So let's talk about that. Now, in order to prevent such kind of conflicts, developers usually provided with the isolated branches so that they can work on their branches, and once the development is done, they can do a single merge and they can sync their changes into a single branch. So the git merge command combines separate branches and resolves any conflicting edits over there. So once the developers are done with the specific changes, with the modifications to the source code, later on they can combine those things, they can work on these components, and they can resolve all these conflicting modifications, right? So a merge conflict is an event that takes place when Git is unable to resolve the differences in the source code between the two commits automatically. Normally the Git is having the capability to understand that okay, these are the two different piece of source code which is getting pushed to a remote repository, but in any case it does not happens automatically. There is any kind of conflict which arises over there and Git is not able to take any kind of decisions. So in that situation we will be able to get a merge conflict. Now it could be a possibility that one merge can happen successfully, then the next merge will be cancelled and will be deferred due to this merge conflicts. So Git can automatically merge the changes only if the commits are on different lines or the branches here. So if at any moment of time you are diverting from the process, you are having some different lines of source code, so that is where the merge conflicts comes into the picture. Now what are the different kind of merge conflicts which we normally face? The main types of merge conflict is, first of all, there are 2 points where we can say that a merge can happen or can come into a conflicted state. The very first one is the started the merge process. Now if at any moment of time there are changes in the working area or working directory and we are moving, or these changes are getting moved to the particular working area of the stage area of the current project. So during the merge activity itself, the particular merge will fail because there are some changes or there are some kind of modifications which is right now present over here in the working area. So in this case conflicts happen due to pending changes. Now for instance, you have done some modification to the changes. Now you were planning to do the commit, but before that you felt that I want to do some kind of merge. Now since there are some pending changes which is available there into your working area, so what will happen that your merge will definitely fail there itself. So before even starting, before even initializing the merge, as in particular pre-check, your merge activity will fail there itself. So in that situation you have to either remove those pending changes or you have to resolve those pending changes before even going for the merge activity. Second, during the merge process, definitely if you are getting some conflict, so the merge conflicts gets originated. So the failure during the merge process indicates that there is a conflict between your local branch and the branch being merged, right? So you're trying to move the changes from one branch to another, so it means that there are some particular conflicts which is coming up in the particular branch in which you are trying to do the merge. So in this case, Git resolves as much as possible. So if there is any kind of difference in the source code, in the commits and the different line of source code there, so Git automatically try to resolve it as much as possible, but at any moment of time it's not able to do, it's not able to manage. In that case, a particular human interruption is required so that we can merge or we can resolve these particular conflicts manually there. So these are the two types of situations in which a particular merge can enter a particular conflicted area. Now, how to resolve these merge conflicts? Now, what happens that in order to resolve these merge conflicts, the simple way to do this is that we open the file which is in conflicted status. Now, once that is done, you do the required changes. Whatever source code you feel you want to proceed, you will select that source code, you will use that source code, and once the addition or editing of the file is done, so what you can do is that you can run the pretty much straightforward command called git add to add that file to the staging area. And then what you can do is that you can do the git commit activity so that the particular merge conflicts can be resolved and you will be able to see a merge here. Now this is something which is known as one of the best approach for resolving the merge conflicts, because even if it comes up, if Git is not able to handle it automatically and it requires for you to manage it manually here, so definitely in that situation we have to open the source, we have to select that which portion of a source code we want to keep, do the modifications manually, and then follow the traditional approach to perform a custom commit. So git add and git commit command you will be doing there in that situation to have a particular final merge executed all together. So this is the steps which we can follow to perform a custom to resolve a particular custom merge conflicts over here. Right now, the various git commands which we can use to resolve the conflicts here. Now git log --- merge is a command which helps us to list down all the commits that are causing the particular conflict here. If at any moment of time your merge is failed down and you want to see that what are the different commits which is causing the issue here, probably you might be ignoring some commits which is not that much important, or you can manually override the content so that those conflicts data can also be added, and whatever the changes you are trying to add, that also should be modified. Second command, git diff command, you can always use the to check the difference between the particular files between the repository. Git checkout is something which you can use to particular check out a file, so that if you want to check out the latest content of a specific file or a folder, so in that case you can make use of this git checkout command here. So git checkout command will definitely help you to understand that how we can go for or how we can do the checkout of this particular repository or a particular file here. Right, so then we have a command called git reset --- mixed. So git reset --- mixed is a command to undo the changes of to the working directory, and whatever the particular changes you have, so that will be undo there, and it will be able to do the undo changes to the working area and the staging area here. Now then we have git merge --- abort, which will be used in order to exit the merge process and return back to the state before the merge and begin. If you're not able to resolve the merge conflicts manually also, so in that situation we will be aborting the merge situation or a git merge over here. And the last one is git reset. So git reset command is used at a time of merge conflicts to reset the conflicted file, so that what we can happen that we can go back to the previous situation before even starting, or the state before the merge activity was started there. So git reset will eventually help me to reset all the files which is in conflicted area, and latest files will be checked out and will be replaced. So these are some couple of commands which we can actually use in order to resolve the merge conflicts into a Git repository. Now that was something which we were trying to understand, that what exactly the Git merge was there, and how the Git merge originated, and how the Git particular merge conflicts gets created, and how we can resolve it. Now let's go for a proper demo on this one so that we can understand it properly, that how exactly Git merge conflicts really work and how we can resolve it. Now this is the Git bash which we have installed to run some Git commands. Now in this one, first of all, I'm going to create two repositories. So I'm going to run the command called git init a, that will initialize a repository, git init b, that will initialize a b repository here. So two repository I have got, a and b. Now in basis a, what I'm going to do is that I'm going to add the remote. So git remote add origin. So I'm just trying to add the origin over here. So the origin over here in this one is the Maven build. So this is a repository which I have got into my GitHub account. The moment you do this, what next you can do over here is that you can run the particular next git pull command to fetch the latest updates here, right? So next, move to the particular next command here. Now when you do this, what will happen that all the changes which is present in the remote repository or central repository will be available here also, right? So you will be able to see some couple of files all together here. Now the same activity you have to do in the particular B directory also, or in the particular B repository also. So you have to add the URL, the remote URL here, and in this case also we are trying to fetch the particular values here. Now what will happen that we will be doing some modification in the particular A repository, and then we will be pushing that change to the remote repository, and then through the B when we try to push the changes. So in that situation we will try to see that what really happens. Do we really get the merge conflicts? Because both of them, although is trying to do the changes to the central repository, but these two repository represents two different local repositories, probably in two different developers machines over here. So that's what we are trying to replicate here. So I'm going back to the A directory here so that I would be able to do some changes altogether. So I'm just opening readme.md file here. So pretty much I'm just trying to add some particular changes over here to this particular file. So this is what we are trying to do here. Now let me add some particular additional and a particular new line over here in the file, and then save the content. Now once this is done, I will be able to see that yes, there is a particular change which is done all together here. So you will be running git add command and then git commit command to save the commits all together. So we are giving a particular commit here so that we will be able to identify that this is something which we have committed from a repo A. Now once this is done, I will be doing the push activity so that I can push these changes to the particular remote or the central repository here. So exactly what we did over here so far, we have a particular downloaded remote repository in a repository A, and then we are doing some changes, some modifications, and once those modifications are done, we are pretty much changing or putting up that new commit all together to the GitHub repository. So this is what we are trying to do so far over here in this one. So this git push activity will take the particular access, right? So when I do the particular push activity here, so if the credentials are saved, then that's fine. Otherwise it will ask for the particular username and password all together here. So that will be asked by the particular activity here. So it will ask for the password. So all you have to do is that you have to just share that password, and your git push activity should be passed on, or should be done there. And as you can see, the changes really got moved to the GitHub repository. Now sometimes the credentials get expired, so you may get some particular message saying that you have to put some password there. A particular interactive window will be open there, and you have to prompt, or you have to provide that password, and according to that it will proceed further, right? So this will eventually help you to move the changes into the GitHub repository altogether. So all of your changes will be pushed to the GitHub central repository, right? After some time, it really pushes my commits to the remote repository. It will take some time depending on the network connectivity and the kind of changes you are trying to upload. So now since my particular repository is done, so what I can do is that I can further go back to the particular directory here. Now what we can do is that we can go back to the beat repository over here, and in this case also I'm just trying to do some modifications. So for instance that I'm just trying to do the changes here to the readme file, again a kind of a changes in this one. Now in this case I'm trying to delete this line, the last line I'm trying to delete here, or a couple of modifications I want to do over here, like added data from repo, and then furthermost I want to have, let me do some arrangement, like let me have this data added all together over here, or I can add it, yes. So data is added and this data is removed. So the idea is that we can do different kind of reshuffling of the data up and down so that we can understand that how it really works. So I have shuffled the data, I have removed a couple of lines, and let's see that how it works, right? So I have even added some couple of lines over here. In this new line I have added one line, I have removed from the last, and this particular line I have shifted 5-6 line up over here. Now let's me save this file and then run the git add command. After this we are going to run the particular commit here saying commit from repo B. Once commit is done, same activity, pushing it to the remote repository. Now let's see what really happens. Now when we are trying to push this particular change to the remote repository, after the change was pushed from repo A, it will throw an error saying that the particular, due to the conflicts, the updates are simply rejected here, right? So in this case what really happens, that because we are having a different stream of source code in a remote repository, and from local repository you are trying to push some different line of source code. So what next you need to do is that first of all you need to do the activity called git pull --rebase origin master. So you're going to pull the changes from the remote repository so that you should be able to get some particular content all together in this particular repo B over here. Now the moment you run this, let's wait for this activity. Now once that is done, you will be able to see that you are seeing a message saying that conflicts are there. So first of all you have to resolve these conflicts and then it will be proceed further. You have some couple of options, like you have to resolve the conflicts manually, and because Git is not able to handle it. Otherwise, once the Git conflicts is resolved, you can run git rebase hyphen continue. If you want to skip this commit, so you can say git rebase hyphen skip. And if you want to abort the particular this rebase here, so in that case you can run git rebase hyphen abort. Now since we want to manage, or we want to resolve this conflict manually over here, so what we need to do is that we need to open the merge tool on this one. So once you open the merge tool, from there you will be able to resolve those changes manually and then continue with the rebase. So let's go with the git merge tool here. So we are going to use the command called git merge tool. Now when you run this, so what will happen, that it will process, it will open the normal vi command line over here, and all the files will be processed all together. Now this is the modifications, right, which is which is done over here. So we are just trying to see that which particular file or what resultant file we want to configure here, right? Now in this case, since you are able to see that this is the final file which is present, and here exactly the merge conflicts comes up, because you can see that 3 different files are given to you in this side. So you have some files in which you added new 2 lines, and here you added this line there, this artifact will be there. Now here you also added this particular new line instead of having this line default here. So what exactly happens when you scroll down, you will be able to see that where exactly is the particular issue, or what are the different modifications you've done there. So in this one, if you scroll up and down, you will be able to see that what exactly it happens. So the main area of conflict is first of all this area, So this should not be there as per Git, as per the normal file, but yes, if it is there, so we have to see whether we want to continue or we want to proceed with this particular specific file or not. So yes, so I will say that okay, let's remove this line. Let's not let's copy this line. Let's delete this line here and add the line over here in this one, and place this line also from here. So this is what I'm just trying to make use of here. Now here I just want to have the particular line pasted. Okay, deleted. So this line I will okay. So I have added this line in the final. I'm just trying to resolve this conflicts manually. I'm just editing this file here, trying to remove this one, this one, this one, and this one. So this is how my particular final file looks like, and I am good to go to this one. Now you have resolved the conflicts manually by doing the modification to the file. Now just press :WQ, save the file over here, and then close the other files also. Right, so this is how I have done the modifications, and I should be able to continue further now. So what I'm going to do is, like, I'm going to run command git previous --- continue. Now once that is done, so the particular commit which or the modifications which you have got over here, so that is something which is totally done, and yes, the rebase is finalized over here. Now again, this is the manual modifications which you have done, so you should be good to go to push to remote repository. So again, in this case, what you're going to do is you're going to run like git push. Before that, if you want to check the particular git log, so you can check the particular git log over here. So the last commit which we were try to doing, like commit from repo B, is also available over here, right? So A and B, both changes are present now, so we should be able to push the changes to remote repository. So it will take some time to do the push. And as you can see, it's trying to put some content, so we'll still wait for the final confirmation so that we can assure that yes, all the conflicts is resolved. And yes, that's correct, all the particular conflicts are resolved, and we should be able to see both commit A and commit B into the repository. So let's go back to the GitHub portal and see that if we really got those particular commits in that. So let's, when we access our particular repository on GitHub, so we should be able to see that we have got an activity that the commit is checked in there. So if you go to the commits part, you should be able to see that you have got these commits gone process altogether. If you click on any one of the commit, you will be further able to see also that what different changes you actually moved. So this is the way that how you can resolve the conflicts, and you can take care of the changes from two different developers or for two different push activity. So that's it for this particular demo. I hope you liked it. Thanks everyone. So we are done with the demo, and we have understood that how we can resolve the merge conflicts with the help of some couple of commands. Now in this, we really have got an understanding that how the different ways of merge conflicts really gets originated, and how we can help or we can make use of some Git commands to resolve those things.
In this session, we will be talking about the differences between Git and GitHub. So before we begin, let's have a look at all the topics we will be covering today. We will begin with learning the basics of Git. Then we will check what is GitHub, followed by different commands that we use in Git. Then we will see a hands-on demo of implementing all those commands in Git. There we will also see the process of pushing the file onto the GitHub. Finally, we shall see the difference between Git and GitHub. So without any further ado, let's get started with what is Git. Git is the most commonly used version control system that helps in tracking changes made to the files. We may have a record of all the changes that have been made in a file, and we can also revert back to a specific version. Git simplifies the process of software development with the help of easy source code management. Before we go on further with Git, let's first see what is meant by version control system. Version control system, as the name suggests, keep a track of all the versions of a file. This helps all the team members to be on the same page and collaborate with each other. Now, let's continue with Git. Git is not only helpful and popular among developers, but also helps non-technical people to keep a track of all the files they have been working on. Git helps in the process of collaboration and permits changes made by multiple people to all be merged into a single source. Then, Git automatically merges the changes so two people or different sources can even work on different parts of the same file and later merge those changes without losing each other's work. This is especially useful when the projects are really big and many people are involved in it. Now, after Git, let's have a look at what is GitHub. GitHub is a service hosted on the web where all the projects are stored. Every project on GitHub has its own repository and its unique URL. Git provides a graphical interface to store the files and helps team members to coordinate on the project from anywhere. GitHub provides several access controls and collaboration features like wikis and basic task management tools for every project. Now, when we are all aware of Git and GitHub, let's have a look at some prominent commands used in Git. First command is the git config command. This command helps in configuring values on a global or local project level. It helps in configuring the username and the email address when we first begin with Git. Second command is the git add command. It is used for adding any number of files to the Git repository. It could be one file, two files, or an entire folder. All of them could be added to the repository using this command. Then we have a git diff command, which helps in finding and viewing changes made to the file between the commits. Fourth command is the git init command. It is used to initialize a repository. Whenever we run this command, a folder by name .git gets created in the repository, and from that time, .git will start tracking any changes made to that folder. It also creates a new repository and a branch, and that branch is created by default and is called the master branch. Fifth command is the git commit command. This helps in committing all the work we have done in terms of files we have changed or added. Everything will be committed with a single command. Next command is the git reset command. This command helps in undoing the local changes made to the state of a Git repo. Moving forth, we have the git merge command. This command helps in joining two or more development histories or branches together into an active branch. Then we have the git status command. This command helps in having the status of all the files that got deleted or created or got modified. The status of all such files can be obtained with the help of git status command. Ninth command is the git push command. This command is used to push the contents from the local repository to the server. Last and the 10th command we will see is the git pull command. This command is used to fetch and download the content from the remote repository and update them to the local repository. Now, after we know the commands, it's time to see the implementation of these commands. Let us start the demo. So we will begin with opening our git bash. Then in the git bash, the first thing that we will do is to configure the username and the email ID. So for that, I will type git config global user.name Simplilearn at _ GitHub. Then I'll configure the email ID. In this I'll write global user.email. For this I don't need double quotes. The email ID that we are using is siddham.bharat@simplilearn.net. Now we can see in the configuration list whether these things are there or not. So for that we will check. We can see our username and user email are present here. So moving on to the next step, we will check the address of the remote directory. For that, we will type pwd. We can see the location of the remote directory is C users rahul.arun. Now, here we can see the location of the remote directory. Moving forth, we will create a folder in this directory from where we will create all our Git repositories. So for creating the folder, I will type make directory. Let's create it with the name Git _hub. Now let's navigate to this folder. We can see the location of the folder. So we will go here. Here we can check our folder is there, GitHub. When we go inside it, we can see the folder is empty. So let's create a repository for this folder as well. So we will create this repository with the name comparison. Now let's navigate to this folder. Now we can see a folder with the name comparison is here. When we go inside it, we can see the folder is empty. This is the folder that we will be using as a base for all our repositories. Now let's initialize a repository for this folder. For initializing, we will use git init command. Here we can see an empty Git repository has been initialized to our folder. Now let's go back to that folder and check. Now when I enable the hidden files, I can see a .git folder appears on the screen. This .git folder is created. If we get into the folder, we can see a bunch of files are there. We can see directories and configurations. Make sure you don't make any changes to any of the directory. Now we can see something called the master appears on the screen. Whenever a Git repository is created for the first time, it creates a branch. The name of the branch by default is the master. And that is why we see this master on the screen. Now let's create a few files for a folder. We will use the touch command for this. Let's say touch alpha.txt, notepad alpha.txt. We can see a notepad appears on the screen. In this, we shall write alpha, beta, gamma. We will save it and close it. Now let's check the status of these files. Now it shows that no file is yet committed and there are untracked files that could be seen in red. Here we can see alpha.txt is untracked. Now we can either specify the name of the file or simply write git add dot. Now to add this file, we can give a particular name or we can simply write git add space dot. Then let's check the status once again. We can see there are no commits yet and the files that were earlier red have now become green. It also shows a remove command in case we want to unstage or undo the changes. Now we can go on and commit this file. For commit, we will type git commit -m and let's say we type beta gamma. We can see one file changed and one insertion made. Moving forward, let's check the log of all our files. We will type git log. It shows the commit ID. There's the author name, the email ID used, the date and the commit message is also there on the screen. Let's make one more commit. We will do the same process again. We will type touch beta.txt, notepad beta.txt. Another notepad with the name beta opens on the screen. In this again we shall type alpha, beta, gamma and let's write delta also this time. We will save it and close it. Let's now check the status of this file. We can see there's one untracked file that is beta.txt. So we will first add this file, then we shall commit it. Let's type alpha gamma this time. We can see one file changed and one insertion made. Now let's check the log again. We can see the commit IDs for two files now. So now when we have all the changes and the files with us, we may want to share these files with someone else. And this is when GitHub comes into picture. So when we want to push these files from our local repository to our remote repository or from our system to our GitHub, we will need to use the git push command. So now I will go to my GitHub. I have my GitHub account logged in. I will create the repository with the name comparison. The description is optional, So leaving it for now, we will simply create the repository. Now we will copy this git remote add origin URL, go back to our git bash, paste it here and press enter. Now we will type git remote -v. Now we will type git push -u origin master. We can see the GitHub login opens on the screen. We will put our username and password here. So I will put. Now, as we can see, all the things that we wanted have been pushed onto our remote server. So let's go back to GitHub and check. When we come back to our Git server, when we come back to our GitHub, we shall see alpha.txt and beta.txt are present on the server. Let's open this. We can see in alpha, we have alpha, beta, gamma. Then let's open beta. Here we can see we have alpha, beta, gamma and delta. These are the notepads that we just created and they have been pushed from our system to our GitHub. I hope you guys understood the demo, as it is going to play a major role when we discuss the differences between Git and GitHub. Finally, let's see the differences between Git and GitHub. Git is a software that can be installed directly onto our systems, whereas GitHub, as we saw in the demo, is hosted on the cloud. Then Git can be used offline. We don't typically need an internet connection unless we need to access the GitHub, whereas GitHub can only be operated when we have an internet connection. Next difference is Git is something independent and can be used without GitHub, whereas GitHub has nothing to do unless we make repositories in Git, which means it cannot be used without Git. Then Git is a version control system that helps in source code management, whereas GitHub provides centralized hosting of the code on the cloud. Next difference is Git does not work according to a graphical user interface, while GitHub is a simple graphical interface. Next difference is Git is a command line, so it operates on several commands like commit, merge, push, pull, etc. Whereas GitHub is a web-based service, so it has nothing to do with command line. Then Git is released under the GNU General Public License, which is an open source license. It ensures that the software is free for all its users. Whereas in the case of GitHub, there are two tiers, a free tier and a paid tier. In the end, let's have a look at the competitors of the two. As a competition, Git has Mercurial, Supervision, IBM, Rational Team Concert, and ClearCase. While for GitHub, the competition is Bitbucket and GitLab.
Git is the most popular distributed version control system used for source code management. It helps coders to coordinate and track their code. We have compiled the most important Git interview questions that you might face in a Git or DevOps interview. So without further ado, let's get started with Git interview questions and answers.
So let's just get into those source code management, and we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have 4 options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way using git init allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, using the bare way, you have a different commands for setting that up. So it would be git init --bare, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are 2 ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 56DE0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are 2 ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you wanted to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that. And that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. And that will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into into GitHub. And this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local Git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository.
Now with that, we have come to the end of our complete Git and GitHub tutorial. If you like this course, don't forget to like, share and subscribe for more such helpful content. Until then, thank you and keep learning with Simplilearn. Thank you for watching and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn's YouTube channel and click here for similar videos. To nerd up and get certified, you can check the description box below.